My name is Chris Vickery, and I'm the Global Business Manager for Thermoplastic Composites here at ZOLTEK. After studying materials and processes in industrial engineering at Purdue University, my career has spanned over 25 years in materials and composites with companies like GE Plastics and Sabic, Sumitomo Bakelite, and PolyOne. Joining ZOLTEK, I worked with compounders and end-use companies to help understand and maximize the benefits that carbon fiber can bring to thermoplastics and to develop materials that highlight those properties that can be achieved. During this webinar, I'll give a brief ZOLTEK company overview, discuss carbon fiber for thermoplastics, review a few case studies, and wrap up with a brief summary. ZOLTEK was founded by Zolt Rumi in 1975 and consisted of the sales of chemical process equipment, waste heat recovery systems, and pollution control systems to plants, refineries, and electrical power plants throughout the Midwest. In 1988, with the acquisition of Stackpole Fibers, we entered the carbon fiber business as this market was beginning to service high-end aerospace applications. In 1996, ZOLTEK purchased an acrylic fiber plant in Hungary, including their complete chemical operation. ZOLTEK became the first and still only carbon fiber facility to polymerize textile-based precursor for the manufacture of industrial-grade carbon fiber fabric. ZOLTEK expanded this business model into Mexico in 2007, becoming the world's largest supplier of industrial-grade carbon fiber. And in 2014, ZOLTEK was acquired by Toray, and since that time has continued to invest in the business with additional capacity and technical expertise. ZOLTEK has made several capacity expansions in our production facilities and plans to add additional capacity as needs grow with key markets such as wind energy, automotive, and thermoplastic compounding. To show the breadth and scope of carbon fiber and how ZOLTEK and the Toray Industries participate in this market, we serve as the world's largest supplier of regular and large tow carbon fiber products. Typical applications and markets for regular tow products, which are Toray products, include aerospace and aviation. These can be served with multiple products that offer a variety of performance specifications. Here at ZOLTEK, we are the world's largest manufacturer of large tow carbon fiber, supporting rapidly growing markets like wind, automotive, 3D printing, oil and gas, civil engineering, industrial, sporting goods, energy storage, and infrastructure. The next slide will highlight the different products and supply chains associated to the carbon fiber. This page outlines the various forms of carbon fiber, starting from the pan precursor all the way to some applications we participate in today. ZOLTEK polymerizes and spins its precursor, carbonizes it into carbon fiber tow for direct pultrusion or for filament winding. ZOLTEK and other suppliers produce multi-axial and unidirectional fabrics that support infusion and RTM molders that manufacture composite components. And lastly, the chopped and milled materials support material manufacturers at the injection molding community and make carbon fiber, SMC, and thermoplastic carbon fiber reinforced components. I would now like to discuss the ZOLTEK carbon fiber products for thermoplastic materials. The key ZOLTEK product is our PX35 carbon fiber tow. This product is both affordable while delivering a strength-to-weight performance equal to or better than many high-end carbon fiber products. Our product is a 7.2 micron diameter, 600,000 tensile strength, and 35 million tensile modulus carbon fiber with a carbonization content of about 95%. This industrial-grade carbon fiber is a good mix of properties, price, and global availability to service multiple markets. From the standard product, ZOLTEK also produces a wide range of derivatives, including oxidized products, chopped fiber, milled fiber, and various fabrics for different weights and constructions to serve a multitude of industries. The ZOLTEK chopped carbon fiber portfolio is shown here. We develop chemistries that are specific to various resins to ensure the physical properties of the finished compound are maximized in the final molded part or assembly. From our workhorse grades of -45, which are designed primarily for nylon, to our -65 for polycarbonate and thermoplastic polyurethanes. In addition to these core products, our product portfolio also consists of -83, our high temperature sizing that is designed for resins like PPA, PEEK, PAI, and PEI. -95, another sizing chemistry designed for high temperature nylon resins that does offer enhanced properties over those of 4,5. And -02 that can be used in pulp and paper resin making operations. We also have a milled fiber product offering that is classified based upon conductivity. One resin sizing that I skipped over is our 5.2 product, which is designed for polypropylene resin systems. In the recent past, some of you may be aware of our product -55, which is also for polypropylene sizing. I will cover these sizings in greater detail in the subsequent slides. In addition to the primed chopped fiber, we also offer a recycled product offering that is classified as post-industrial recycle. These grades can also be ordered in the same -45 for nylon and -65 for polycarbonate, and are designated by our nomenclature RSM, which stands for Recycled Standard Modulus. Both the prime grades and the post-industrial grades offer ease of distribution and compounding processes, consistent flow rates in resins, and have lot-to-lot consistency and bulk density for ease of feeding in your process. All of these characteristics help improve the property performance in your resin system. There are so many benefits that thermoplastics can bring to the design of your component or product. Some of these include fast cycle times compared to thermosets and other manufacturing processes, an expansive portfolio of resins to choose from that include materials that have chemical resistance, high heat capabilities, economical resins, color and texture varieties, and many other characteristics, all while being able to be manufactured with low scrap rates as compared to other resin technologies and processes. All of these allow designers and OEMs to explore design features and freedoms while incorporating fewer secondary operations and processes for part consolidation. All of these benefits, plus various forms of recyclability and programs, make thermoplastics a natural solution to many OEMs. However, with all these benefits come some limitations that include higher tooling costs versus other processes, long lead times for tooling, and higher costs that can affect overall CapEx formulations. On the performance side, thermoplastics offer limitations that can include temperature, mechanical properties like creep, flame resistance, and poor resistance to solvents and hydrocarbons, just to name a few. At Zoltek, we have years of experience in thermoset resins, as we've serviced the wind market. However, our entry into thermoplastics has been an evolving process. With the purchase of Zoltek by Toray, there has been a strategic direction launched for resources and equipment to support carbon fiber in the thermoplastics industry. Evidence of this commitment is in the state-of-the-art compounding and molding equipment available in our St. Louis facility and the people that support those activities. Along with the twin screw extruder capable of compounding material from polypropylene to high temperature resins, we will work with all resin suppliers to build physical property profiles that can be cross-referenced against those resin suppliers' internal development with carbon fiber. We've also invested in an 85-ton electric molding machine. This allows us to process most resins in-house with the various carbon fiber loadings. These can also be tested against other filled materials, most notably glass-filled materials, which allows us to build performance profiles for materials that aid both end users and compounders alike. And lastly, our attention to details as it relates to our customers and their equipment. We also have various feeding equipment that allows us to mimic the multiple ways that carbon fiber can be compounded with the resins, from small side feeders to gravimetric hoppers to direct feeding into the mixing barrel. All of these methods can prove critical in ensuring a quality compound that maximizes the fiber length in the finished product. To highlight our investment in working with industry partners, I'd like to cover a couple of slides that were compiled by LyondellBasell and have been presented by their technical and commercial teams in the past. The ZOLTEK -55 product was used in the development of carbon fiber reinforced polymers for the automotive industry and TPOs. Carbon fiber was able to offer LyondellBasell a lower density, which equated to final part weight reduction of 50 to 60% versus conventional steel structures and 10 to 20% reduction versus aluminum structures, all of which translates to improved fuel economy and lower emissions. Enabled new design features like thinner wall thicknesses while still offering stiffness, which enabled new designs and features versus current glass-filled solutions, the prevention of corrosion versus metal systems, and with the typical market pricing of carbon fiber, applications that were targeted towards only premium vehicles and racing programs were now more realistic and more cost competitive. With all these benefits and features, the performance backs up with the following data. The standard TPO, the thermoplastic polyolefin offers excellent melt flow rates, good tensile, and excellent elongation, with low flex modulus and HDT properties. However, as you can see, with just a small amount of carbon fiber into the thermoplastic matrix of 5%, you can considerably change the property profile. Sacrificing some melt flow, you will dramatically increase your HDT performance and increase in flex modulus, while losing some elongation. Over the next couple of slides, we will illustrate the change in properties as we increase the loading of carbon fiber from 5% all the way to 30%. This shows the change to 10% carbon fiber loading. And now 20% carbon fiber loading. This increase starts to highlight the superior performance in flex modulus and tensile strength. And finally, 30% carbon fiber loading. You can see that the standard TPO resin is capable of increasing the flex modulus over 80% in performance, and doubling the tensile properties while only sacrificing melt flow rates, but still manageable both from a processing and design perspective. All of these increases in properties lead to a new way of designing and manufacturing TPO systems. Thinner wall thicknesses with superior flex modulus and tensile properties while designing around elongation shortcomings. As the development of carbon fiber systems are rapidly evolving, so too are the products we can offer to this industry. The following slides outline our newest patented sizing technology for olefin chemistry, our PX35-52 size product. As you can see, the -52 sizing offers improved tensile strength and flexural strength of 30% versus the baseline polypropylene chemistry. This increase in both tensile and flex offers few ways to benefit, with thinner wall thicknesses or potentially lower loadings of carbon fiber depending on part design and performance requirements. The performance story continues with improved properties in elongation with 50% increase, notched IZOD impact with a 78% increase, and unnotched impact with a 132% increase over the standard 5.5 product. All of these improved properties translate into design flexibility and freedoms to the engineering community as they work to create and manufacture the next generation of body panels and components for automotive, industrial, and consumer goods. This new product offers all these improved properties and is a patented technology, a competitive solution to compete against glass-filled nylon, is ready and available for sampling now, and has been tested in-house with various resin suppliers. Carbon fiber is also playing a growing role in 3D printed thermoplastic applications for strength, modulus, and conductive applications. From prototyping and application to full-scale part production, carbon fiber is allowing design freedoms that could not have been achieved before. Milled and chopped carbon fiber are actively being used in this market. The milled carbon fiber is unsized, and the shorter fiber length is less likely to cause clogging issues in printer heads for smaller printers. For large-scale printers, a 6 mm chop fiber length is being used, and these printers can print over 100 pounds per hour. These are popular for the manufacture of prototypes or small-scale production tooling, and our high-temperature size product, which is the -83, is being evaluated for in-autoclave applications. Additionally, advancements in materials and printing technology are allowing for finished part production for applications that do not have large-scale production numbers, saving on tooling costs, which were once a major factor in not being able to produce a cost-effective part. Our full line of product sizings cover the range of thermoplastics from polypropylene to polycarbonate to high-temperature PEEK and BEI. ZOLTEK has the product to meet your 3D printing material needs. The last product I'd like to cover, being developed with ZOLTEK carbon fiber, is carbon fiber reinforced thermoplastic tapes. With the advanced processing technology and high volume tape placement in injection molding, the ability to withstand high stresses and succeed in performance is now attainable with localized tape reinforcement. Carbon fiber thermoplastic tapes can be made with various resin systems, from polypropylene to nylon to PPS and other high temperature resins. This helps with the compatibility with the final product that is being produced. The use of carbon fiber reinforced tapes allow for design freedoms like thinner wall thicknesses, designing in lower performing or cost-effective resins, designing in or removing of features like bosses and ribbing, and since the primary part structure will be increased in property performance with the use of continuous carbon fiber tapes. The placement of these continuous reinforced tapes enhance the overall performance of the component or injection molded part. The finished part will have a combination of enhanced properties that are more in line with carbon fiber reinforced tapes. These typical properties of those tapes are a tensile modulus of 115 gigapascals, a tensile strength of 1,135 megapascals, and a flexural modulus of 110 gigapascals. All of these properties are based on a 50% fiber volume loading in nylon resins. However, the properties can be tailored based upon the weight fraction, which can vary as low as 30% and go as high as 65 to 70%, depending on the resin systems and the flow properties of that base resin, and the suppliers of the carbon fiber reinforced tape. Lastly, with all these advancements in processes like 3D printing, thin wall molding, and two-shot injection molding, the capabilities of combining either chopped carbon fiber or utilizing continuous carbon fiber tapes, the design possibilities are endless in determining the property profile desired in the final part. Please reach out to us if you'd like to inquire about these products containing ZOLTEK carbon fiber. To show the advantages that carbon fiber can bring to thermoplastics, I will cover a couple of case studies in the following slides. The first application that I'd like to highlight is a consolidated inner door module assembly. Polypropylene reinforced materials are being considered as a top material candidate due to design freedoms, economics, and lower cycle times. The typical application allows for part consolidation while improving part performance. Compounds are being tailored to meet specific performance, and in some cases include a hybrid structure reinforcement system that include both glass and carbon fiber. This allows the engineering community to take advantage of the key performance attributes that both of these reinforcements offer: strength, stiffness, cost, and modulus. For some filled polypropylene applications, the benefits from lower carbon fiber loadings while maintaining fiber length offers high stiffness and improved ductility using carbon fiber. Nylon has also been a key material for the part consolidation opportunities in automotive interiors and can also be loaded with carbon fiber, therefore increasing some performance characteristics like HDT creep, while adding carbon fiber which naturally reduces specific gravity, creating a lighter finished component. Similar applications are under discussion within the recreational vehicle and industrial markets as well. The next case study involves DLFT, direct long fiber thermoplastic manufacturing. DLFT compression molding technology allows for the addition of continuous fiber or tow directly into the mixing extruder. DLFT uses two extruders and thus separates the compounding of the plastic and the fiber mixing steps. Both the extruders can be individually optimized for their specific functions. The key advantage is that the material is subjected to lower levels of stress typically seen in injection molding, resulting in less fiber breakage and increased mechanical properties. Materials targeted for this type of process can be tailored to the specific fiber content and typically can be produced in a few different resins. I would like to thank you for taking the time to listen to this webinar. In closing, I would like to do a brief summary of the topics presented today. ZOLTEK continues to develop new products that can be a good addition to many markets. Our new polypropylene sized carbon fiber product can find homes in automotive structures and is being tested in industrial and consumer goods. With Nylon 6, we've seen a development in automotive horizontal panels like deck lids and roofs, and can bring electrical and static dissipative properties to consumer goods. With processing technologies like DLFT for thermoplastics, we have seen higher fiber length retention, which equates to higher physical properties in the final finished part or component. And lastly, I would like to mention that ZOLTEK is working with various thermoplastic carbon fiber tape manufacturers. These developments will allow for a cost-effective solution for continuous carbon fiber strength and modulus in resin systems that can be included into injection molding and other manufacturing processes. Please reach out to us for more information regarding the availability or ways to get these thermoplastic carbon fiber tapes. Thank you for taking the time to celebrate National Composites Week 2020 with us, and we hope that you found the topics and material presented useful. If you have any specific questions, please feel free to reach out to me directly with the contact information presented. Thank you and have a great day.